All right, for this video, we're gonna take a look into more depth, into more detail regarding coterminal angles. We did talk about a little bit when we started Chapter 4, and you can see the definition there. Again, coterminal angles, they're two angles that have the same terminal side. You're going to see we can have infinitely many angles that they're really at the same point in the unit circle. I could represent them as many different positive angles and many different negative angles. Here's a good example. You see this right here. What I have in red, this is the angle that I'm looking at. Now, if I measure this, if I go counterclockwise, remember this is positive. If I go counterclockwise, I know as I go to each axis it's 90 degrees, so 90 plus 90 here is 180, plus 90 there. This is 270 degrees. So if I went counterclockwise, this would be 270 degrees. Now, the other way that I could go the other way. I could, from the initial side, remember I always start at the initial side, I could go down. So if I go down, I'm going clockwise from here to here. Well, I know I'm only going 90 degrees. But since I'm going clockwise, it's got to be negative 90 degrees. So here's an example. 270 and negative 90 degrees, they're coterminal. It's really, you're at the same exact point in the unit circle. You just note them two different ways. And, you kind of notice, here's kind of the trick. You can kind of see how 270 and 90, how they, if you take away the negative, if you add the absolute values, 270 plus 90 is 360. Okay, because that's one revolution in a unit circle. Like you could look at negative 90. Let's say you have negative 90 degrees. If you add 360 to it, well, that gives you 270. Okay, so it's almost like saying, all right, if you're here in the unit circle, if you add 360, then you're going to go, like if you're here, if you add 360 to this, well, that means you go counterclockwise, 360 degrees. You end up at the same point. And if you measure it positive, it's 270 degrees. You could go the other way. You could either start with 270 and you could subtract 360. Now all that means is if you're at 270 degrees, which is right here at the terminal side, if you subtract 360, then you're going to go clockwise because you're subtracting. Well, it doesn't really matter. If you subtract 360, you go all the way around, you still end up at the same point. But when you subtract 360 from the 90, or excuse me, when you subtract 360 from 270, it gives you negative 90. All right, so all we did, basically what we did, we just kept going around and around and around in a circle. It doesn't matter which way you go. If you keep going around in a circle 360 degrees, whether you go clockwise or counterclockwise, you end up at the same point, so you're always at a coterminal angle, which shares the same terminal side. So to kind of sum it up, again, kind of talking in circles here, literally talking in the circles here, if theta is the degree measure of an angle, then all angles with the measure, I'm going to put theta, I'm going to put plus 360k, or you could put theta, you could subtract multiples of 360, you're going to be at the same point in the unit circle. Okay, now you're probably asking yourself, what does k mean? K just means the number of revolutions. How many times do you go around the circle? I could go around a circle 500 times. If you go around in a circle 500 times, you're going to end up exactly where you started. Like if I did this, if I start here and I went around 4 times, 1, 2, 3, 4, guess what? I'm still here. All right, so that's why we do multiples of 360. Now, if I do this in radians, well, I'm going to do the same exact thing, but if it's radians, I have to replace 360 degrees. 360 degrees is 1 revolution. So 1 revolution in radians, as we learned previously, is 2 pi. So I literally just take this. If you take whatever angle you have and you add multiples of 2 pi to it, or subtract multiples of 2 pi to it, then you're at the same point in the unit circle. They're coterminal. And again, k is the number of revolutions. All right, let's kind of put this together. Let's work at some examples where we're given an angle measure in degrees, and then also when we're given the angle measure in radians. And you can see right here from the directions, I want to find one positive and one negative. There's infinitely many answers you could have for either. Okay, let's start with 1, 70 degrees. If I want to find, let's say, another positive angle to it, well, real easy. I could just add 360 to it. So if I do 70 plus 360, That's going to give me what, 430? So 430 degrees is the same exact point in the unit circle that 70 degrees is. Now let's say you want to get a negative angle. Well, let's start with the 70. Let's do the opposite. Let's subtract 360. I know that's going to give me a negative. So if I subtract 360 there, let's see here, we're going to get what? Negative, what's this? Negative 290. All right. Let's skip to number 4. Now, number 4, the first thing you notice, it's not within 1 revolution. Now, it's going to be easier to deal with degree measures when it's in between 0 and 360, because you know exactly where it lies. Well, to get it in 0 and 360, well, I know if it's more than 360, I'm going to subtract 360 from this. When I subtract 360 from 660, that gives me what, 300? And I know this would lie in 300 degrees. This would be in the 4th quadrant. So I know where 660 degrees is. It's just more than 1 revolution. Okay, so there's a positive angle. If I want to get a negative angle, well, I'll do the same thing. I'll keep subtracting until I get a negative. So I'll subtract another 360. So it's like subtracting 2 revolutions from the original 660. So if I subtract 360 from that, I get negative 60. So all 3 of these right here that I have circled, 660, 300 degrees, and negative 60 degrees, they're all different numbers, but they're all at the same point in the unit circle. All right, let's do 2 that's in radians. All right, let's pick some good ones in radians. Let's see here. All right, let's look at 5. Now, look at 5. You always want to have it between, if it's in radians, 0 and 2 pi. I know if I made this a mixed number, let's see here, 4 goes into 8 2 times, and there'd be 3 left over. This is 2 3/4 pi. Oops. So I know that's more than 1 revolution. Now, I could add 2 pi to this, but you know what? I'm going to keep subtracting 2 pi because I know if I subtract 2 pi from that, it's still going to be within 1 revolution. So if I take 11 pi over 4, if I subtract 2 pi, don't freak out. You have fractions. A lot of students get to this like, oh, how do I do this? 2 pi, right? It's over 1. If you got the common denominator of 4, 11 pi over 4, right, your common denominator is going to be 4. So if I multiply this 1 by 4, I multiply this 2 pi by 4, so I get 8 pi. 8 pi over 4 is the same thing as 2 pi. And if you subtract, then you wind up just getting 3 pi over 4. This kind of makes sense because that's what was left over. So if you went the other way, 3 pi over 4 is going to be left over. You're going to be at the same point in the unit circle. Now, if you want to get a negative radian measure, I just keep subtracting. Just like I kept subtracting 360, I'm going to keep subtracting 2 pi until I get a negative answer. So I'm just going to work with this 3 pi over 4. I'm going to subtract another 2 pi, and I already know that 2 pi is the same as 8 pi over 4. So if I subtract 8 pi over 4, I get negative 5 pi over 4. So here it is. If I circle all these, 11 pi over 4, 3 pi over 4, negative 5 pi over 4, they're all different, but they're all at the same point in the unit circle. All right, let's do one more. Let's skip to number 8. Okay, number 8 we have a negative. Now I want to make it positive. I want to have it so it's in between 0 and 2 pi. So here I'm just going to have to keep adding 2 pi to it. Now since my denominator is 6 for the negative 13 pi over 6, the 2 pi, right, if it's 2 pi over 1, I multiply this by 6, I multiply 2 pi by 6, it comes 12 pi over 6. 12 pi over 6 is the same as 2 pi. When we add that together, we get negative pi over 6. So I still have a negative 1. To get a positive 1, well, just do the same thing. Just keep adding 2 pi to it. So if I keep adding 12 pi over 6 to this, we get 11 pi over 6. So that's my positive coterminal angle, another negative coterminal angle. This is what we started with. All right, so real easy. If you have it in degrees, you can either just add 360 to it or subtract 360. Reminder, yep. You got that? All right, that's pretty much it. Converting between doing degrees and radians. I'm just going to stop. All right, ciao.